Hey guys, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please let me know. Hello everyone, I hope that I'm live right now, guys. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please let me know. Good evening, everyone. Good evening. Good evening. You guys are able to listen to me properly. Is there any issues with the audio or the video, guys? No issues. All perfect. Okay, great. So, did you guys try to practice what we had done in our yesterday's class? Did you guys try to practice what we have done in our yesterday's class, guys? Yes? Did you guys try to change the number of epochs or something like that? So, Meha, you had taken epochs as 5,000. Did you get the right results or what was the scenario? Meha, you took 5,000 epochs, right? Still no answer. Still no got the answer. Okay. Okay. So maybe do one thing, guys. Maybe change the number of change the number of neurons. Okay. Instead of using 8 neurons, try to use 2 to the power 4 neurons, 16 neurons or 32 neurons. Try to do that, guys. Okay. Don't go for 10,000 epochs. That is not going to work. Okay, do one thing, guys. Do one thing. Change the number of neurons that are present, guys. Instead of using 8, increase the number of neurons to 16 or 32 or 64 or something like that. Always make sure when you are increasing the number of neurons or decreasing it, it should be in the values of 2 to the power n. Okay, try to make a combination of those. Try to increase the number of epochs to 2500 as well as the number of neurons as well. Try to see if you guys are able to get closer to the result or not. Okay. Increasing number of validation set, I don't think so that is going to help, but yeah, definitely you guys can try it out. So syntax error aa raha tha 9th line of code mein, how to fix that? Read my code and your code, look into spelling mistakes, look into capital and small mistakes. Okay, that is how you will be able to solve your error, because the code I have written in the class itself, the video is still available online. You guys can just reference that out and check what mistake you are doing. Mansi, I'm pretty sure you are making a mistake. Sab check kar liya, वापस करो, 10 बार करो, 20 बार करो, you are making a mistake. Syntax error aa raha hai, that means you are making a mistake right over there. Most likely there will be a mistake of not you have missed out on some particular part of code, or you have made a spelling mistake. That is, or you have made like capital and small error itself. So you will have to try that out. Okay. Maybe number of brackets, that is also sometimes a major issue. I have used two particular error mein comma missing aa raha tha. Most likely the number of brackets is something that you are missing out right over there. Maybe I have used 2 brackets, you have just used 1 bracket. Check the number of brackets as well properly. Where I have put the brackets, where I have not put the brackets. Because in some of the lines I forgot to add something, so I had to go back and then re-add it. For example, right over here, model.add, what Taken BLR has said, he has missed the deep, dense significance itself. So his particular line of code will not be able to work properly because he has missed the dense that I had added 2 minutes after that. So you will have to check that up. Okay. For those guys who are getting this comma mistake itself, most likely you will get the mistake in this particular line, model.add, then the neurons itself, number of neurons and everything. So most likely you guys haven't added the dense word right over there. So if you guys see the particular code that I have done, I have also forgotten to add dense, and after 2-3 minutes I added the dense part to that. So most likely you have not done that. That is the problem that you are facing right over there. Okay. Check the yesterday's video correctly, guys. Okay. Okay. So now that okay, for those students who are not getting the correct results, try to increase the number of neurons as well as the number of epochs. Okay, try to play with them. Okay. So can you explain why we are using ran.random 2 times? Karthik, why is your name Karthik? Is there a reason behind it? The reason behind it is your parents named you as Karthik, right? In the exact same manner, when the people who created NumPy, the random package itself, they created it in such a way that if you want to use it, you have to use it like that. Yes, Shubhi Rathod has written it correctly almost. Okay, this is what you guys have to follow. Why is there 12 right over there? I don't know. That should be L2, not 12. So yeah, this dense that is there, that is what most of you guys must be missing. Okay. Shubhi Rathod, it is L2. You have written 12 right over there. That is the error in this particular code. Look into it. You have written 12 right over there, Shubhi Rathod, instead of using L2. See, these are the kind of mistakes that you guys will be making. It could get right answers for small numbers only. I took epochs 5500. Aisha, you have to increase the number of neurons as well. Most likely the neurons are less, so it is not able to learn properly. Increase the number of neurons. Okay. Okay, so let's start with today's class, guys. Let me share my screen first of all with you guys. Today we are going to learn. So yesterday we saw how to deal with data that is like numbers, right? Oh, what did I do? We saw particular algorithm that we were doing according to some data that was numbers. But for object detection, right? We're not going to work upon numbers, right? What are we going to work upon? What will be the data for object detection, guys? Is it going to be numbers? What is it going to be, guys? What is going to be our data that we're going to feed in? What is going to be the input for our AI model, guys? Can somebody let me know? What is going to be the input for our AI model, guys? Photos, you guys can say pixels as well, but most likely photos, right? Photos are going to be the input for our purpose right over there. So how do we deal with this? Okay, how do we give an input as a photo, and how does an AI work upon photos itself? So what we learned yesterday is called as ANNs, okay, or artificial neural networks. These are the most simplest forms of deep learning architecture that is there. That is called as ANN, guys. Okay, you use ANNs for some basic data that is there, for example, numbers and all this kind of stuff. For photos, for videos, or all these kind of stuff, you use something called as CNNs, or convolutional neural networks, guys. Okay, convolutional neural networks. Now this is an advanced form of ANN. You can think about it in such a way that has been built to deal with audio based data, to deal with video based data, to deal with photo based data, to deal with some type of signal based data as well. So for all these different things, okay, all these different things you can use CNNs to work over. Now, how does a CNN work? How does an image can be taken in as an input for an AI model itself? That is what we're going to explore in our today's class. Are you guys able to understand this? Please let me know. But for us, we are not going to deal with signal-based data, audio-based data, video-based data. We are going to deal with photo-based data right now. So we'll try to understand how can we do that. Okay. So let's start with a very, very simple question. What is a photo made up of? What is a photo? That is a question mark, okay, not an exclamation mark. What is a photo made up of, guys? Have you guys ever sat very close to your TV screen? Like the old TVs that used to be there, those fat ass TVs, right? Have you ever sat very close to those TVs and you will see small rectangles on the screen? Have you guys ever seen that? You sit very close to your screen and you see small rectangles on the screen of, or even if you be very close to your TV or very close to your mobile phone, you see these small squares that is coming up on your screen, right? These squares are nothing else but are called as pixels. These are called as pixels, guys. Now, what do you mean by pixels? So you must have heard 1080p, right? 4K, 8K. So the P at the very end is basically pixels. What is the pixel density, or how many pixels are going to be there on the screen? Now pixels is basically the most smallest unit of a display. Any display that you use a watch display, you use a mobile phone display, a tablet display, a TV display, a hoarding display, any kind of display that you are using, the smallest unit of that display is going to be a pixel, guys. Now what is this pixel? So pixel is nothing else but just a square that contains 3 LEDs inside of it. A red LED, a green LED, and a blue LED. That's it. And a blue LED. That's it. Every single one of these small squares that you were able to see on your screen, right? That is a pixel. And each of these pixels contains just three particular LEDs inside of it. That is the R, G and B. Okay, red, green and blue. Any color, this is called as the color theory, guys. Any color in the entire world, any color that you can think about in the entire world can be created using a combination of these 3 colors. For example, if I make the red, green and blue LEDs at 100% intensity, then I will get white color. When both R, G and B are at 100% intensity itself. If I switch all the 3 LEDs off, I will get the black color right over there. If all of them are at 0% intensity. If red is at 100% intensity and the other 2 are at 0% intensity itself, then I am going to get the red color. Similar to that, if red is at 0% intensity, blue is at 0% intensity, green is at 100% intensity itself, I am going to get the green color right over there. So this is how a pixel works. Now for a computer, it is very difficult to understand images. Please try to understand it. Computers cannot understand images. There is no perceivable way of understanding something for a computer that is just visual in nature. But we want our computers to understand these images, right? So for that, we have a way of converting these images into mathematical representation. Okay? Any image can be converted into a mathematical representation, guys. How can we do that? So let's take up a particular any image. Okay, any image that you take it up, the image can be and what is the size of a pixel? Okay, so every pixel that is there is 1 by 96th of an inch. The size of the pixel, any pixel that is there is 1 by 96th of an inch. So just making sure that you guys know that as well. So any image is going to be a digital image itself. So a digital image basically means that the image is created or is comprised of small parts that are the pixels itself. Each of these pixels contain 3 particular LEDs inside of it. That is the R, G and B values. Now these R, G, B values can be represented in a mathematical way in which 0 represents 0 intensity, 0% intensity, that is the R is actually closed off, and 255 represents the highest intensity that is 100% intensity, guys. 100% intensity, that is what is represented by 255. So here any pixel can be represented in a mathematical way as, for example, if it is a red colored pixel itself, it will be 255, 0, 0, where 255 represents that the R value is at the highest, whereas the blue and green are at the lowest. So I can represent every single pixel in this particular format. Are you guys able to understand this or not, guys? Please let me know. Are you guys able to understand this or not, guys? Please let me know. Yes? So instead of taking a colored image, we will think about a black and white image, guys. We'll think about a black and white image. So let me take up the white pen. So let's consider this as a black and white image. In the case of a black and white image, let's draw this circle right over here. So in the case of this black and white image itself, you are having this circle in the middle that is white in color. So any pixel that is going to be there, if it is black, that means it is 0, that it has 0 intensity. If it is white, let's assume this pixel is white in color. If it is white, then it has 255 intensity itself. It has 255 intensity. 255 means that that LED is at full light. This is a black and white image, guys. This is not a colored image. There is no concept of RGB here. Either the LED is on or the LED is off. These are the only two options available right over here. You can reduce the intensity of the LED. You can have the LED at 50% intensity. So it is not completely white. It is a little bit grayish in color itself, and so on and so forth. Okay. Okay, so Sake, for those who are living under, so Sake, I think so you are like a particular SpongeBob SquarePants. If you have seen, you're like Patrick from SpongeBob SquarePants, who lives under a rock and hasn't used YouTube for a very long period of time. So let me bring you into the modern world by helping you out. Okay, so on YouTube, if you're not able to see things clearly, your particular video is not clear, there is an option of going into the settings and increasing the quality of the video to 720p or 1080p, whatever is available. At the highest, you will be able to see screen clearly. I'm not even writing anything. I'm just drawing some certain shapes right over there on the screen. But nevertheless, you will be able to see the screen clearly. If you're still not able to see the screen clearly, maybe you're wearing specs, okay? So maybe there's dust, or maybe there is some kind of glare on your specs itself. Clean it up. Clean your particular laptop screen, clean your mobile phone screens. Maybe there is some kind of grease or dirt right over there. If you're still not able to see things clearly, please visit a doctor and get your eyes checked. That is what I will be able to suggest to you. Okay. Okay, so right over here, guys, as you're able to see, there are only two options right over there. Either it is going to be, the LED is going to be switched off, or the LED is going to be switched on. Okay, now yes, the LED can reduce its intensity as well. So for example, if it is going to be 125, that means it is at 50% intensity. So I will able to recreate this into a matrix. Let's see, let's recreate this into a matrix, guys. So now having these two pixels, I'll divide this like this. These are, let's assume these are all the pixels right over there on our screen. So in this particular way, I can create a matrix around it. In this matrix, you are having all these pixels in one row. So you'll put up the intensity in one row. So it is 0, 0, 0, 0, 0, 0, 0. Then you'll having the second row 0, 0. Let's say 30, then you are having 40 or 100, or let's say 100 right over here, then 0, 0. Then you will have 0, 30, 125, 255, 255, 125, 0, and so on and so forth. So this is the, like, this is the actual representation of the image, for black and white image, when it comes to mathematics. How can we convert that image, what we are able to see, into what the computer is able to see? So this is what we are able to see visually through our eyes, guys. This is what we are able to see through our eyes. This is what a computer is able to see through his, like, particular computer itself. So this is a robot right over here, right? This is what the computer is able to see. So this is a very crude example. Let us look at some like good examples right over here. So let us go here and go with MNIST dataset. Let's go to images. So this is a good example to make you guys understand. Maybe let's take this up. I'm not able to see things clearly. Open in a new tab. Open image in a new tab. Okay, so as you're able to see right over here, on the left hand side, it is a black and white image. On the left hand side, you are having a black and white image where the black color intensity is shown from 0. So if it is 0, it is white. If it is 255, it is completely black. Okay, if it is 255, it is completely black itself, guys. And this is the representation of the image when it comes to the same image, when it comes to what the computer is able to see. All the zeros represent the white spots, whereas 255 represents the darkest spots. As you're able to see, some is 7, some is 32, some is 122. So those represents the grayish area right over here, the gray pixels that is there, where the intensity of black is not that high. But the intensity of black is not that high, guys. Are you guys able to understand these representation of images when it comes to, like, from the what we are able to see and what the computer is able to see? Are you guys able to understand this, guys? Please let me know. Are you guys able to understand this, guys? Please let me know. Yes. So now these images that we are able to see, these are in the format of a two-dimensional matrix. Okay, when it comes to a black and white image, it's a two-dimensional matrix that we are able to see right over here. How can we give it as an input to a neural network? This is going to be very complicated, right? Not that much, it's actually pretty simple. So what did the researchers said was, so when you look at a picture of Sake, if you're not heard me correctly, I'm not going to repeat it. Okay, I don't like repeating stuff. I repeat stuff 2-3 times, then I continue further. Okay, so I cannot repeat again for you. If you are still not able to understand, this is a YouTube video. Scroll back. If you just want to listen to me again, just scroll back, listen to me again. That is the beauty of using YouTube. Okay, so right over here, guys, when you see an image of a, let's draw an image right over here. Okay, I am not very good at drawing. So what do you think this is? It looks like a fucked up Doraemon, but still, like, what do you think? What type of animal does it look like? Okay, what type of animal does it look like, guys? A puppy, a dog, right? How the fuck can it be a cat? Like, which cat has ears like this? A cat has ears like this, not like this. The drooping ears is basically what identifies it as a dog itself, right? This is what I will draw if I want to draw a cat. I will just draw like this. These are the horns of the cat. I don't like cats. Okay, so like I said, guys, so how were you able to think that this is a dog? Like, it looks like a fucked up Doraemon, right? But how did you guys think about it? Like, okay, it might be a dog. You might have seen the whiskers, right? You might have seen the nose. You might have seen the tail that is there. You might have seen the ears that are drooping right over there. So individual features, your brain tries to identify individual features that are there, and according to those individual features, you take a random decision that it might be a dog. It might be a dog right over there. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. You look at individual features, the whiskers, the nose, the particular ears, the drooping ears, the tail, and then you like, okay, these are the different features that are there, and hence this might be a dog. Okay. In a similar manner, we want our AI model as well to be able to find features. Now, how does the brain actually work? The brain will first figure out lines. It will first see different lines that are there. Then it will then slowly and steadily form shapes through those lines. Maybe a triangle for the nose, maybe a circle that is you are able to see for the mouth. Okay, it will try to find shapes right over there. Then those shapes it will correlate to some extra features. For example, the tails that you have seen, right? It looks like a tail, it might be a tail. It looks like a ear, it might be a ear. It looks like a nose, it might be a nose, right? And then through that you take up a random particular decision that okay, it looks like a dog. In the exact same manner, a CNN also works. Okay, again, CNN is also like your ANN. It has multiple layers to it. Okay, so layer 1, layer 2, layer 3, layer 4, and so on and so forth. There are multiple layers to a CNN as well. The job of the first few layers is to find out these basic like lines. Okay, maybe a particular straight line, maybe a horizontal line, maybe a tilted line, maybe a tilted line like this, maybe a line at a different angle itself, and so on and so forth. The first few layers tries to find different type of lines that are there inside the picture. Now, how is it able to do that? It is able to do that using Snapchat. I don't use Snapchat, but you guys use Snapchat, right? You guys use Snapchat right over there, or am I the only, like, you guys are also like me? You also don't like Snapchat. I don't like the concept of it. Like, what the fuck is a streak? I don't want to maintain any streaks with anybody. Why the fuck should I send you a particular picture every single day? Heh. And that too, you guys send me a blank picture. Like, what is the use of that picture, right? So what do you do on Snapchat? You use different filters right over there. What does these filters do? They add certain type of design to your image, right? They add certain type of design or certain type of filter to your image. In the same way, CNNs also use something called as filters. But these filters are used to find out different type of lines that are there inside of your particular image itself. Let us look at this. Let us look at this from a picture standpoint. Horizontal filter CNN. This is not a very clear image. This might be. Okay, so on the left hand side, you guys are having your image. This is your image, guys. It's not a very clear image, but I hope so that you are able to see the image. Now you use something like these. These are called as filters. These filters are again nothing else but just matrices. Okay, matrix that is there. You use these matrix on the particular image you slide. So these are, so your original image, right? Your original image will be very big. It will have a lot of different pixels. If you are taking up an image, let's say 30 pixels by 30 pixels, it is going to have 900 pixels right over there. A lot of pixels. Now, what you're going to do is you're going to take this particular filter on top of it and you're going to roll it over. You're going to roll it over. You're going to place it on the first 9 particular pixels on the top, and then you're going to take up matrix multiplication. You're going to take up matrix multiplication, guys. You guys know matrix multiplication, right? Or like that is also something that I need to teach you guys. I'm not going to teach you guys. Okay, matrix multiplication I'm not going to teach. So you take up the image. Let's assume this is our image, guys. So this image has a lot of different pixels, right? A lot of different pixels right over here. You take up your filter. You place your filter right over here. This is your filter, guys. This is your filter. You place your filter right over here. You take up the matrix multiplication of all these different particular pixels that is there, and then you put the answer right over here. Now, if there is a vertical line, it will give you a certain value that identifies that, okay, in this particular area of your image, there is a vertical line. That is how the matrix multiplication works. That is how this certain particular filters have been created to find if there is a particular vertical line right over there or not, or a horizontal line or a like standing line. So the filters are different based upon what you are trying to find. Again, you don't have to create these filters. That is the beauty of using a particular thing like Keras. It has multiple different filters inside of it. It has hundreds and thousands of filters already present that are working to catch these features for you. So you don't have to create these filters. I'm explaining to you guys how these filters work. Okay, then you will move this particular filter to the next particular line, guys. You'll move this particular filter to the next particular place. So now this will come right over here. Again, it will do matrix multiplication on top of this particular set of pixels. If it finds a particular thing, then it will add it up right over there, and so on and so forth. So continuously you will be shifting this filter all across the image to get a new image, because again, all these particular filters that you have applied will get you a new image that will be there, that will look something like this. That will look something like this, guys. This is what you will be getting. So this is for the vertical edges, okay, vertical filters itself. As you're able to see, it identifies all the different vertical lines that it is able to find inside of the image. These are the vertical features of your image, guys. When it comes to horizontal, so this is particularly filter to find out the horizontal edges, and as you're able to see, it is able to find out all the different horizontal features of your image itself. Are you guys able to understand this? Please let me know. Are you guys able to understand this? Please let me know, guys. Yes, are you guys able to understand this? Okay, great. Now, what happens is you get a new particular image, multiple filters will be there that will be generating multiple new images as well. Now, the first few layers will be working upon finding these line based features. The next few layers will be based on finding shape based filters itself, features. For example, circles that are there in your images, okay, squares that are there in your images, triangles that are there in your images. So the next few particular layers will be dedicated to that. Okay, again guys, I don't like repeating myself. If you are not able to listen to me properly, if you're not able to understand something, ask me that, I will explain it. Okay, but if you just want me to repeat myself, this is a YouTube video. Just scroll back the video, listen to it once again. But if you're not able to understand, let me know exactly what you were not able to understand. Don't write I didn't understand filters. Okay, what can I do about it? I've already made you guys understand filters. भेजो अगर तुम लोग Instagram और Snapchat use करो, filters नहीं समझ में आ रहा है तो मैं क्या करूँ? I can't do anything about it. Okay. But if you're not able to understand something, tell me exactly what you are not able to understand so that I will clear it up for you. Okay. Okay, so the first few layers, the hidden layers, will be trying to find these line-based small features in your images. The next few layers will be trying to find shape-based features. Okay, for example, circles, triangles, rectangles. The next few particular layers will try to find higher features itself. Now the problem with images are way too big, and matrix multiplication is very computationally heavy. You are not able to understand what is vertical edges and horizontal edges. Like dude, like vertical lines and horizontal lines, that is what it is. हिंदी में मैं explain नहीं करने वाला, sorry. Okay. But in this photo, both horizontal and vertical line looking. So the reason for that is when you are drawing a vertical line, think about it guys, this is common sense. Like these type of questions shouldn't be arising, like it is common sense right over there. When you draw, for example, this particular line, let's take up any vertical line right over here. There's literally no vertical line right over here guys. These are tilted lines. When you draw a tilted line, a little bit angle as well, there is a horizontal component that is there. There's a vertical component and a horizontal component. That is how you get a tilted line. So it is able to find that out. In the first particular image, you are able to see that anything that is completely horizontal in nature, that is not being shown right over there. Anything that is tilted a little bit, that is a horizontal component as well as a vertical component. So only the vertical component is coming up right over here. Again, this is something that is common sense. This is not something that like I have to teach. You have to think about it. These are things like, okay, why do I think that there is a horizontal component coming up right over here? Think. Okay. Okay. So the next thing, what was I saying? I forgot about it. So images, right? Images are very, so all this is basically matrix multiplication that you're doing, right? You'll be doing it thousands or millions of times itself. So very computationally heavy stuff that you're doing right over there. And your code will become way too big. It will take up a lot of resources from your computer. It will take a lot of time to just train the particular AI model itself. And you don't have that much time. So you need to decrease the size of the image as well moving further. What we are doing right over here is called as the convolutional layers. The layers that are there to make features, to figure out features from your images, are called as conv layer or convolutional layers itself. There is another set of layers that will be there in the architecture called as the pooling layers. They call as the pooling layers guys. The aim of the pooling layers is to take the same image and reduce the size of the image itself. So what the pooling layer will be doing is, for example, if it takes this particular part of the image, right? Let's take up this particular part of the image. The pooling layer will say, okay, this is a filter right over here. Pooling layer will have its own filter, guys. Again, pooling layer will have its own filter right over there. It will say that, okay, out of these 9 particular boxes that I'm able to see, what is the highest? This is just one example. It might do the pooling in many different ways itself. There's just an example. It's called as max pooling, which really says that whatever is the highest pixel value inside of this particular box, that will be the value that I will be specifying right over here. For example, here the value is 19. So that is what I will be specifying, the max value out of these 9 boxes. Now all these 9 boxes have been reduced to just one box in the new image. If we move further, again it will take up, let's say, the stride. So there is something called a stride of your filter. So if it moves, right, if it moves, is it moving just by 1 pixel? Is it moving just by 2 pixels? Is it moving just by 3 pixels? Like, what is the scenario? How much the particular filter is moving to the next particular, doing the next particular pooling itself. So let's assume the stride is 1. So it will come right over here itself. Again, it will see all these 9 particular boxes. It will find the maximum value. Let's say the maximum value comes to be 100. So it will put 100 right over here. Again, it will be moving further. Okay, it will be coming to this particular location. Again, it will find the maximum value. Again, it will put right over here. Let's say it's 50, and so on and so forth. In this particular way, you are reducing the size of the image by like 2 or 3 pixels on both the ends. Depending on how much stride you are taking up. If you are taking up 3 strides, it can be reduced from 3 to 6 particular pixels on both the ends itself, from length and width. So it reduces the size of your image while preserving the features as well. While trying to preserve the features as well. Let us look at an example for this as well. Let's take up a max pooling example. Max PWL pooling. Max pooling image. So as you're able to see right over here, guys, here as well they have applied a max pooling on the image of the cat itself. So this was the original image. Then they have applied max pooling right over here. This is the image that they were able to get. So the size of the image reduces while preserving most of the features that were there of the images, making your entire matrix multiplications and everything way too faster. Now this entire concept of reducing the size of the image is called as dimensionality reduction. The technical term for this is dimensionality reduction, guys. What do you mean by dimensionality reduction? You are basically reducing the different dimensions that were there. So the features, you're reducing the features, you're reducing the size of the image, you're working on a smaller image itself, making your code go much faster. So these are the two concepts that are used by convolutional neural networks to basically understand what is happening in your image. And finally, whatever features it was able to find out after reducing the size of the image, after finding out the lines, the shapes, the different parts of the particular picture itself, after doing all this, at the end it is a ANN itself. You attach an ANN at the very end to understand all these inputs, all these different features that are there from the image itself and then give you an output. But pooling the image quality will be decreased by a lot. When you're pooling an image, it will decrease your image quality by a lot. But you cannot use 4K images to train your AI. For that, you need a supercomputer to help you out. For example, let me give you a very simple example, a very shit quality. A very shit quality open sourced LLM. Let's leave LLM. A ChatGPT rival that is open source, that is like the code for ChatGPT is available on the internet. If I want to train it on my own, okay, I want to train it on my own itself, on my own data, it is going to cost me $800. The code is available. I have a system. I cannot train on my system because my system will go bust. It will never be able to train. I'll have to take computing resources from AWS. Amazon, I will have to take up some good quality CPU and GPU on rent and train it. The cost of that will be $800. Now, yesterday, you guys we tried to train an AI, right? Did we get the right answers? So we didn't get the right answers, right? So what did we need to do? We needed to change the new number of neurons, then rerun it, retrain it. Then we had to change the number of epochs, then retrain it, and so on and so forth. This is where the problem starts arising. Because for every one of these trainings, I'm not going to get my answer on the very first run. Every time I'm retraining my model, $800 I have to pay extra. So you have to make sure you have to find the fine balance between, is it so important to use 4K images, or can I pull it down to such an extent that the features still remain intact? Here as well, as you're able to see the whiskers, we are able to see it. We are able to see the eyes. We are able to see the ears. We are able to see most of the features of the cat still being there in the image itself. So you cannot pull it a lot. If you do it a lot, then nothing will be left. But a little bit of pulling will be required to make your particular algorithm, your AI model run faster. Okay? Are you guys able to understand this? Please let me know. Are you guys able to understand this concept of pooling, guys? Please do let me know. Okay, great. So tomorrow what we're going to do is we're going to do this with a small data set called as the MNIST data set, MNIST, MNIST data set itself. It's a good beginner based data set to learn. Pooling नहीं समझ में आया. Basically pooling समझना है तो चश्मा खोल लो. चश्मा खोलने के बाद सब चीज ब्लर ब्लर दिखता है ना, ढंग से नहीं दिखता है, इमेज क्वालिटी डिक्रीज हो जाती है. 1080p में अगर तुम्हारा डेटा काम नहीं कर रहा है तो उसको 420p में करना पड़ जाता है ना, तो क्वालिटी खराब हो जाती है इमेज की, वीडियो की क्वालिटी खराब हो जाती है. दैट इज व्हाट पूलिंग इज. दैट इज हाउ पूलिंग वर्क्स. इट टेक्स अ बिग साइज इमेज एंड मेक्स इट स्मॉलर, मेक्स इट कंप्रेस्ड, makes it of lower quality so that it is faster to use. Okay, basically when you watch movies in 1080p but you don't have the data to do that, you reduce it to 320p, 360p itself, so the image quality, the video quality decreases. So it makes the video, the data that it is using smaller, right? In the same way, right now what we are trying to do is the image quality is way too high and we are doing matrix multiplications. Matrix multiplication is very costly when it comes to the time it takes to do the computation. So we have to make that image as small as possible while like preserving the features itself. Okay. Okay. So right now I'm going to give you guys the attendance for today's class. Tomorrow we will be creating a practical project based on CNN itself. Please make sure that you are able to do this. Harsh Prasad, try to increase it to 32 neurons or 64 neurons itself. Play with the numbers. See, it's a trial and error process. You cannot expect that you have to get the results at one go itself. One of the chat GPT, the concept of GPT that is there is since 15 years. The concept of GPT that you guys are currently using is since 15-20 years. That is the concept that has been there. But chat GPT took 15 years to be able to create to such an extent that you are able to use it. Why? Because at one go you cannot get the right answer in this. You have to change multiple things. You have to add more layers, you have to add more neurons, you have to increase the number of epochs, you have to decrease the batch size itself. These are the different things that you have to do. Okay, so you have to do a lot of trial and error to get to the right answer. That is the reason why people are called as data scientists, not as software engineers. Why? Because they have to do this research. They have to sit and do this trial and testing like a particular scientist itself. Okay. Okay, right over here guys, I provided you guys with today's attendance. The attendance link will be closed exactly at 9:06. So please start filling up the attendance right now. At exactly 9:06, the attendance link will be closed. Exactly 9:06 guys, the attendance link will be closed. Please start filling up your attendance. We'll meet in tomorrow's class and we'll continue from right over there. Thank you so much guys. Bye bye.